So we're going to talk about tidal power. But before we do that, we need to talk about what causes tides. So on this image, you can see there is the sun, okay, but there is the moon. And what you'll see, and don't worry about neap and spring tides, but basically, where is the blue raised up around the earth is when it is like closest to like where the moon is located, and it is and the opposite side of where the moon is located. And so you have to remember that the earth rotates on its axis and it goes around every 24 hours. And so the moon does rotate around the earth, but it takes 28 days. And so it's the earth's rotation on its axis and the gravitational attraction between the water on the earth and the moon. Again, the Earth and the moon are gravitationally attracted to each other, but the solid Earth can't really move much, but the water can a little bit. So you see high tide, where on that top image, it would be kind of like the north part of the globe. And then as the Earth rotates on its axis, essentially, what will happen is you'll have a low tide and then a high tide again and then another low tide. So in any day, you get two high tides and two low tides. So that is what will happen. And so what I want to show you, actually, we'll go on this slide, is in more extreme latitudes, more northern or more southern latitudes, far away from the equator, you get huge differences in tides. So this image here is of the Bay of Fundy, and the people you see in this one picture are walking on the ground, and the arches are these big arches that it's kind of people are on the ground walking around, and then there's people kayaking there. So the difference between high and low tide there can be 20 or 30 feet. The boats, if you see in this bottom right hand corner, the boats are laying on the ground, okay? And the dock is way above where they're at. Again, a big difference between high and low tide, 20, 30 feet at times. And so that is how tidal power works. Tidal power works where, so it could either be like this first image with this, like, looks like a windmill, whereas the tide flows in, it's going to cause that windmill or that turbine, that blade to spin. And as it's rushing in, as it spins, that motion is used to move a magnet and a coil of wires to generate electricity. Or in the upper right-hand corner, you see it almost looks like a wall, and that's called a barrage. And what happens in that is at high tide, they trap that water, and then as the tide goes out, they have that water trapped, and then they let the water fall during as the tide goes down and during low tide. And falling water, you can use to move a magnet in a coil of wires to generate electricity. You can use that for the motion. So both of these are tidal power um, ways of that. Again, tidal power is going to be in oceans, not in rivers. And where is this going to work? It is a disadvantage. It only works in select places where the difference between high and low tide is pretty extreme. So, like Bay of Fundy, actually, that area, like in Canada, has has tidal power, but you don't have it in a lot of places. It's on Earth. It's a lot of places it's not going to work. So that's a big disadvantage of it. And it's going to destroy estuaries. So again, if I'm blocking with a wall or I'm putting all of these like windmills in the water in these coastal areas where a river estuary, again, is where the river flows out to the ocean, super important in the life cycle of a lot of oceanic creatures and freshwater creatures. It's going to destroy those estuaries or cause damage or habitat loss to them. So that's a definite downside. So those would be your disadvantages. Again, your advantages, if you think about how it works, it's going to be renewable. Tides are happening. That's are always going to keep happening with the moon. We're not burning, so I don't have any of my CO2 emissions or other air pollutants and things like that. So that is tidal power and how tides work and the advantages and disadvantages of it.